All right, so we're going to talk about intermolecular forces. You might have also heard that as IMFs. That is the attraction between two or more molecules. I hope you don't get that confused with intramolecular forces. So an easy way, like you think, when you think internet, like the internet is how you interact with other people all over the whole entire world. But if you have intranet, I don't know if your school or your maybe your job has something called intranet. That is just within that particular school or within that particular job. It's not, you can't communicate with people everywhere. So there are differences between intermolecular forces and intramolecular forces. So intramolecular forces you might be familiar with. Ionic bonds are intramolecular forces, how the cations and anions are attracted to each other. Covalent bonds are also intramolecular forces. They're actually the bonds between the sharing of the valence electrons. There's the covalent bonds are actually intramolecular forces. And then lastly, it's the metallic forces. It's the metal cations and the mobile electrons kind of flowing between the cations, the sea of electrons. Those three are intramolecular forces. They're within a compound. Intermolecular forces are between a compound and another compound. So let's talk about those guys. Okay, so there are three main IMFs. The first one being called hydrogen bonds. This is deceiving because hydrogen bonds are not really bonds. They're not bonds, but they're called bonds because they're very strong in comparison to the rest of them. These guys are really strong. You might have noticed them as called H bonds. And what they are is when a hydrogen atom of one molecule is attracted to a highly electronegative atom of another molecule. The highly electronegative atoms I'm talking about are F, fluorine, oxygen, and nitrogen. These are the only ones that hydrogen can be bonded to make hydrogen bonding. So for example, what I mean by that, let me grab a pen. What I mean by that is, let's take water for example. Here's what water looks like, and it's one water molecule and another water molecule. These are the covalent bonds, not the IMFs. Okay, these are the covalent bonds within the water molecule. Okay, and we know that oxygen is much more electronegative than hydrogen. So the electrons are going to flow a lot more around the oxygen atom than around the hydrogen atom. So this is going to be slightly negative, and we're going to denote that with a delta, with a minus charge. And these guys are going to be slightly positive. Okay? Same goes for this guy. Electron's going to flow towards the oxygen, making this slightly positive, and this slightly negative. Okay, and we know that negative charges and positive charges attract each other. So we're going to have a very strong attraction here. This is our H bond. Okay, this guy is responsible for the boiling point of water being pretty high. It's responsible for how things freeze and the way the crystal structure is. It's responsible for a lot of things within water that makes water water. This hydrogen bond is pretty important, and it's pretty strong. It's a very strong high attraction from one water molecule to another. Another type of IMF is dipole-dipole. This is when attraction between oppositely charged regions of a polar molecule. Now don't forget, in a polar bond, we have one that's highly electronegative atom bonded to another non-electronegative atom. So not as electronegative as fluorine, oxygen, and nitrogen, but pretty close. So electrons here are going to flow towards the chlorine, okay, making this positive, this negative. Same thing goes over here, making this positive and this negative. And again, we know that negative and positive attract. Very similarly to hydrogen bond, but these guys are much more different in electronegativity values than these guys. So this is not as strong. So this guy here is the dipole-dipole interaction.